All right, in this video, we're going to talk about basic classes and objects. And we're going to start with the circle class, and we're going to make a circle class. I'm just going to be pausing it so it doesn't take so long. So I'm going to be making the example from the book. It's just, and then I'm just going to talk over this. But this is the class declaration, and in Java we make the name of the class capital letters, and then it's camel case after that. So there's the class declaration. The next thing is instance variables. So wait, first, what is a class? A class is a blueprint that will create objects, and objects are nouns. So there are certain attributes that each object has. Maybe those objects can perform tasks, or they can have tasks performed upon them. But the basic idea of a class is that it's a blueprint to make objects. So a class is not, so this, we're not writing an object right here. We're writing a blueprint to create an object. And we start with the class declaration. The next thing are the instance variables. Those are the attributes of what a circle object would have. So in the class, we have to list the attributes, and those are our instance variables. So I'm going to write a couple instance variables. Something to point out is that the instance variables are characteristics or attributes of the circle objects that we're going to create. So each circle has a radius, and that's actually how you say it. There's a has a relationship, and then there's an is a relationship. Is for inheritance, and we'll get to that later on again. But has a means like any circle that I create, any circle object that I create with this class has a radius. So that's an important distinction. Yeah. So the word private here is a visibility modifier. It means that other classes can't directly access this variable, this instance variable. If we made it public, then they could. If we make this private, the only way to access this, to do anything to it, is to do it with getters or setters. So it has to use this class. It has to use methods that are going to be defined in this class. So on the AP test, all your instance variables always have to be private. Otherwise, they'll take off points. The next thing we have are constructors. And we can make those public because we want other client programs like a driver or a runner program to be able to create these objects. So we want them to be able to use the constructors. And a zero argument constructor, for some IDEs, for some integrated development environments like BlueJ is an IDE. For some environments, they automatically create a zero argument constructor unless there is a multi-argument constructor, then it gets rid of. So let me just explain. So the constructors always have the same name as the classes, and this one's going to be a no argument constructor or a zero argument constructor. You can say end. I like to say zero. I don't know why. Zero argument. So what this does is nothing. Usually you can say radius, like you just initialize all the instance variables. This is a double, so I can say 0.0. And this is my zero argument constructor. If I didn't put this in and I didn't have any zero argument constructor, BlueJ would automatically give it a zero argument constructor. If I have a multi-argument constructor like public circle int rad. This is a single argument constructor. I'll probably get rid of this. End single argument constructor. And then this one could be radius gets rad. So as soon as I'll go back to this. So if I didn't have either of these, F7, F8, F7, F8. Okay, so if I didn't have any of that, BlueJ automatically gives me a zero argument constructor. You should always make a zero argument constructor anyway. But if I didn't write one, then Circle would still have a zero argument constructor. As soon as I write, so suppose I didn't write a zero argument constructor, and I did write a single argument constructor or some kind of other constructor that's not zero argument, then BlueJ wouldn't make the zero argument constructor. This would disappear. So even though I haven't written it before I wrote this, it had a zero argument constructor. As soon as I write this other constructor, the zero argument constructor, the default zero argument constructor disappears. So it's always a good idea just to write the zero argument constructor anyway. So that was the point that I wanted to make. Also, when you have an argument for a constructor, it's called a parameterized constructor. So this is a parameterized constructor. And when you're passing something like in a driver, you're passing an argument, but on the inside, like rad here, that's going to be a formal parameter. So when you're passing it to the the constructor inside a driver or a runner class, then it's either called an argument or an actual parameter, and then when you're using it inside the constructor, it's called a formal parameter. But I don't know if that's going to come up too often. The next thing for a class, because we're talking about classes, are methods, and we've seen many methods before, so this I don't think should be a surprise. So we have two basic types of methods, and it's methods that return something and methods that don't return anything. So when you declare a method, this is a method declaration. When you declare a method, the public is the access modifier. If you want it to be able to be used outside of this class, then you should make it public. And this is the return type. So what's the variable that you're going to return? What type is it? And then this is the method name. I'm going to pause it because the bell's going to ring. Okay, so you have to make sure that this is the same thing that this is, like what the variable type. So double, you have to be returning a double. If you say that you're returning like some kind of integer, then it would say that there's like some error. If you have a void method, that means you're not returning anything. And on the AP test, if you accidentally put return inside a void method, then it's automatic points off. So make sure you don't do that. It's because it's not supposed to return anything. I paused it for a long time, but we also have a get area method which returns a double and it does some kind of calculation. Usually in whatever you're doing, methods should have just one goal. So like you can further break it down into like little pieces. That way it's easier to debug, and you can also like compartmentalize jobs so that you really only think of one objective, and if you need to do multiple things for that, then maybe you need two different methods, and then you call those within different places. So here we have a circle class. It's complete, and we don't have a toString, so maybe we need to add a toString, but let's see what happens right now if I create a driver, so runner class. And I've written some stuff already, so it goes a little bit faster, but this I'm going to say is, I should back that up, but I'm going to not have the correct format. So this is creating a reference for a circle object. So I'm creating a circle object here. Well, this is the variable type, the object type, and we're creating a circle, and the reference is kind of like the name of a variable, except for in this case, this stores the address of the object, of the circle. So Right now, we create his circle. Again, this is from the book, so you can see what's going to happen. But we have his circle, and we store the address for his circle inside his circle. So then what I'm going to do is I'm going to create her circle and change, and I want to show you what happens. I think there's a really great picture inside the in the book that it explains what's actually happening. This is the object reference variable. So if I do stuff right now, if I print out, let's just run this. So if I print out her circle, I should get 15 because that's what I made. So I'm gonna compile this and I'm gonna run it. It's 15, of course. Okay. So then what I'm going to do is I'm going to overwrite her circle. So I'll take her circle. But remember, these store addresses for these objects. So really what I'm doing, like we think of it as like copying, but we're really just taking the address of his circle and we're storing it into her circle. So now all the information that was from this is lost and it's overwritten with this information. We'll see in the, like I'm going to run some things, but if I print out her circle, this also should make sense. I should get 20 this time because I overwrote her circle with his circle. So I should get 20. That's easy. Hopefully everything makes sense so far. We'll run it and we should get 15 and then 20. Yes, because I didn't get rid of the print statement before it. Here's where it gets kind of crazy. So I changed her circle. Now it's the same as his circle, but what I'm going to do is I'm going to manipulate his circle. So I'm going to say his circle dot set radius. That's using the dot operator. That's how you call methods. Radius. And the method was called set radius. And we're going to set it to 22.0. But here's the thing. I'm going to print out her circle and then watch what happens. So I'm printing out her circle. So a lot of people might think, wait a minute, her circle has 20 in it. But I changed his circle, and her circle has the same address as his circle. So watch what happens. This might blow some people away, or not, probably not. But 15, 20, 22. So it actually, when I changed his circle, it also changed her circle because I didn't copy anything. I just stored the reference for his circle into her circle. And I'm going to try and find the illustration in the book because I think it's a really good one. I'm going to try and explain and talk over this. So here it is. So when we first wrote this, we have his circle and then there's the address. So it has this stuff. Oh, I don't know if I put those values in. Maybe I did. Maybe I didn't. I feel like I might have. Hopefully I did. And then her circle is pointing to this address in memory. However, when we write the line here, her circle gets his circle, it's not copying anything but the address. So as soon as we run that, then they both have the same address. So if I change if I change his, of course hers are going to change because it's looking at the same thing. It's looking at the same address. That's what happens when you pass like an array or any type of object to a method. You don't actually have to return it because you're passing the reference to the method. So it's passing an address to the method, and then whatever is at that address actually gets changed. Whereas when you pass primitive data types like doubles or integers, those values don't get, like they're copies. You're passing copies, so the copies get changed, but the originals don't. In this case, you're passing an address instead of a copy, so whatever gets changed at that address is actually what is being changed, so it stays that way. I highly, highly recommend that you read over this section. It's shorter than the last one, and I think it's really, really useful. That's pretty much the biggest thing that I wanted to point out. And then we got the review. So if you want to erase stuff, you can say, you can give it a null reference, and then it erases the address, and it doesn't point to anything. That's how you can just erase it and leave it empty, just by doing that. And I guess we could show that, but hopefully that video was illuminating or helpful at all. I don't know. If you read the section, then it should be like really repetitive, but hopefully you did both. All right, bye.